Eureka!
This unit is divided into 5 programs. The program you're about to see is on the incline plane. Then there's a program on the lever. Next comes mechanical advantage and friction. Then the screw and the wheel. And finally, the pulley. But our story begins with the incline plane. You haven't really got enough force to lift that barrel, have you? How much force do you need to lift it? Well, how much does it weigh? So you'll need at least 800 newtons of force to lift it into the back of the truck. How far is that? About 1 meter? How many joules of energy will it take? Well, figure it out. Energy is the ability to do work. Work equals force times distance. 800 newton meters of work, or 800 joules of work, which is the same as 800 joules of energy. But you still can't lift the barrel. There's something wrong somewhere. Perhaps it's because you have to exert your energy all at once. If only you could load the barrel onto the truck a little bit at a time. If you could slice it into 4. Then you'd have 4 200 newton slices of barrel. And you'd only need 200 newtons of force to lift each one. That's easy, isn't it? You're using your energy more effectively now. You're spacing it out over a longer time. But you don't get anything for nothing. Although your force is cut down to a quarter of what you need to lift the complete barrel, each time you lift a quarter of the barrel, you exert that force through 1 meter. Which means that you lift the 4 quarter barrels through a total distance of 4 meters. What you're winning on the force, you're losing on the distance. It's a sort of trade-off. The greater the distance, the less force you need to exert. Very neat. But you can't go around breaking things into pieces just because they're too heavy to lift. If only you had a machine that would allow you to trade increased distance for decreased effort or force. Here's your machine. Yes, I know it's just a plank, but it's also a machine. Try and get the barrel into the back of the truck now, and you'll see why. Magic, isn't it? No, it isn't. It's exactly the same trade-off you got when you split the barrel into 4. The plank is 4 meters long. Instead of moving the barrel 1 meter by lifting it straight up, you're moving it 4 meters by pushing it along the plank. You only need to push it with about a quarter as much force, with only about 200 newtons instead of 800 newtons. But since moving 200 newtons through 4 meters is the same as moving 800 newtons through 1 meter, it will still take roughly the same amount of energy to move the barrel by either method. That's why we can call the plank a machine. It doesn't reduce the energy you need to do something, but it does help you to use your energy more effectively. You think you just made a new discovery? Think again. How do you suppose they built the pyramids 5,000 years ago? They didn't actually use a plank, of course, but a ramp of earth, which is exactly the same principle. And you use the same principle yourself every time you stand on an escalator. Because the plank, the ramp of earth, and the escalator are all 3 examples of the same type of simple machine. They are all sloping, and they are all flat. So physicists call this variety of machine the sloping flat thing. Well, those aren't the exact words they use. They take the Latin-derived word for sloping, which is inclined, and the Latin-derived word for flat, which is plane, to come up with this phrase. So if you're allergic to elevators, why don't you take the inclined plane?